So this is again acid base pair. Just see the difference. Now here, this particular material, whether we can call it acid or base, we can call it both, because it depends on the level at which it is there. If it is treated by acid, this will become base. If it is treated by OH, it will become acid. Now if I do the titration, last time I have mentioned the titration of water with HCl or some sample we have taken and we have added on. If we add say NaOH is added, that means alkali is added, and pH, this is pH. So we have seen last time strong acid and strong base reaction was like this. So the increase was only after 4 or 5 pm to 9. There was sudden increase in pH. In case of, this is for strong acid and strong base. Strong base. If we use in the same way, suppose bicarbonate, then the curve is entirely different. What happens is, it starts increasing so what will happen is, there may be some point where there will not be any change in pH, even if we are adding bicarbonate more and more. Why it is happening? Because now here the HCO3 is in full swing and it can resist. This HCO3, it can act like acid and can resist this particular addition of alkali. So addition of alkali or addition of acid is resisted by this acid bicarbonate or say acid base couple. The same thing happens when it is different. Here it is lower, here it is higher. If we do it with carbon dioxide, suppose carbon dioxide is there, we add HCl. Same way it can happen. So there will be two buffering zones, one at low pH, it will be HCO3 will be active. At higher pH, CO3 will be active. So this particular thing will indicate that acid base pair is useful in controlling the pH range, and generally all our pH necessary for life is pH beyond say 6 to 8.5. Our blood has got a pH of 7.4. Now it is maintained automatically. When we take any acid, you can't take strong acid. If strong acid is there, suddenly pH will go down, it will damage your stomach and everything. But in stomach, the strong acid is created to liquefy the organic matter and do this, but it will be immediately neutralized by the bicarbonate. Now this particular formula, even if it is the formula and other things you did not remember, but this has been used widely to get different compounds. The first, let us consider chlorine. We use chlorine for disinfection. When we add chlorine to water, it becomes HCl plus HOCl. So it creates HCl, strong acid, and weak acid also. So this strong acid and weak acid is there. Now this HOCl, weak acid, is more important for us because it does the killing of the bacteria. This HOCl acts like H plus OCl. So HOCl is called as hypochlorous acid. It gives an H and form hypochlorite. So this is base, this is acid. So when we add chlorine, you will be getting two species of HOCl and OCl. If the low pH is there, then HOCl will be there and it will be definitely killing the bacteria. But if the pH is higher, this will get converted and you will be getting more OCl. That is why we have to see that when we are doing the disinfection, we require somewhat lower pH. Then disinfection is done properly. But if you lower the pH and do this disinfection, it will corrode the metal pipes also. Your water supply pipelines and everything will be corroded. So you have to again neutralize. So HOCl and OCl also form acid-base pair. Now if we are using alum in water, you know alum, allium, Al2SO4 thrice, aluminum sulfate. We have already seen the equations. When we add to water, after balancing you will get AlOH thrice as precipitate plus H2 Al2SO4 Al2SO4 thrice. Sorry. It will be AlOH thrice plus H2SO4. Actually, H2SO4 will not be there. There is SO4 ion. H will be ion because it is dissociated completely. So you will get SO4. But actually, when we have found out in the process, this doesn't happen directly. When Al2SO4 ice goes in solution, Al becomes positively 3 positive, and SO4 2 positive. So there will be 2 Al and 3 SO4 because there is something wrong. So it is converted to Al positive and SO4 ion. In water, what happens is this Al3 cannot exist. Al3 will be initially or immediately hydrated by water molecules. Why? The Al3 being positive attracts all water molecules surrounding it. So there will be OHH, 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 OHH. So this becomes So it is surrounded, it becomes stable. Now in it also, it becomes again finds difficulty in becoming AOS price. So depending upon the pH, it can convert into, this is air, OH plus, it can be air, OH 2, so it is plus, and air, OH 3 precipitate. So these different species are formed in the water. So whenever we are observing alum so dissolved in water, air is formed, but air is immediately grabbed by OH and other things. So some species of OH are formed, some are OH2 formed, some are OH3 formed. Now all these parts act like base and acid. So they are known as acid pair solution. So they will be called as amphoteric substances. Amphoteric substances. So this particular will be able to act both as acid or alkali, and its solubility will go on increasing. Only at very high pH it will become AOS price. At very low pH it will remain A3. Now when we are doing this for coagulation of turbidity, we require maximum positive charge because clay particles are negatively charged. We want to bring clay particles together rather than precipitate. So we have to see that this air gets immediately dispersed with the entire water. That is why we do flash mixing for the water. It should immediately, air should be able to control all the colloids and all the clay particles together. So the process itself will depend upon this particular species formed in the water. In case of chlorine, just as I have mentioned, OCl and OCl, there also we use sodium hypochlorite. Sodium hypochlorite. So we can instead of chlorine, we use NaOCl, which gives directly H plus OCl, or we can use calcium CaOCl2. Calcium hydrochloride or CaOCl, that is calcium hydroxide. This CaO plus Cl2. So this also can give you the OCl. This OCl is helpful in disinfection. Why it is helpful in disinfection? Because this can combine OCl plus H gives HOCl. Form again acid base equation. Now depending upon the HOCl form, the disinfection will be increased. Instead of using direct chlorine, if you use direct chlorine, HCl also is generated. To prevent that, we can use different other salts. You can use ammonia also. When we use ammonia, the chlorine will react with the Cl plus HCl. Now NH2Cl gives NH. Adding chlorine to water or chlorine and ammonia, you will be getting NH2Cl plus HCl. This NH2Cl can form NHCl2 and HCl. NHCl2 can form NCl3 plus HCl. All these compounds are exchangeable. They will be changing their form from one place to another depending upon the pH. This is called as monochloramine. This is called as dichloramine. This is called as trichloramine. So this particular trichloramine is not useful for disinfection. Only these two are useful for disinfection. But they remain for a long time in the water. That is why many times when the water is polluted, we add along with the chlorine some ammonia also, just to make that this, instead of trichlorine, we want to use this monochloramine and dichloramine. These chloramines will remain in the water till the water reaches from the distribution system up to the consumer's tap. Because in between, suppose there is a pollution, there should be chlorine remaining. Chlorine will react with organic matter and will get exhausted. Again bacteria may enter. So for that we add this just to lengthen the process, just to have a buffering action, so that this Cl2, this particular disinfecting action will be continued. We are using this particular CO2. CO2 is transforming the stones into bicarbonate also. You know, when the rain falls, it is a fresh water, but air contains CO2 and it becomes HCO3. So this HCO3 water, when it falls on the ground and it combines with CaCO3 or calcium deposits or any other thing, Ca or any mineral, it will get dissolved in it. So this will become Ca or CaCO3 or any other material. It will get to CaHCO3 twice. That means calcium bicarbonate. These particular things will come, so they will dissolve slowly, limestone and other things. And what you will be getting is this calcium, otherwise which is precipitate, which is stored, which will be converted into solution, and that solution will pass down. When it passes down, this will be creating some voids and some things are there. When it goes down, again it can get converted to CaCO3 and form some deposits of calcium carbonate. Even the marine lives, most of the lives forgot calcium carbonate sheath as a protecting cover. You can see pearls and other things. The main thing is calcium carbonate. Now this particular process of bicarbonate is very important in converting minerals into solutions naturally. When we consider the boiler water, when we boil water, what happens? When the water is boiled, all CO2 gets expelled. When CO2 gets expelled, then the pH rises very high. When the pH rises very high, if calcium is there in the water, it gets precipitated. It is precipitated as CaCO3. So boiler tubes will get coated with CaCO3 and there will not be any heat transfer. So we generally